Alright, hello guys. This would be a quick tutorial on how to set up or how to use the Gridmap Maker to make your own 2D maps. Okay, so let's get to it. First, let's create a new object. Alright, let's call this Gridmap Maker. Okay, now in the Components tab, let's add the Grid Manager scripts. The Grid Manager script. The Grid Manager is the main script for a Grid Map Maker. Okay, so now we have added that in there. Okay. Now the Grid Manager script will contain all the settings that will be required to spawn our map. Alright. Secondly, let's add a new script. Let's call this map spawner. Alright. Let's click this new script, map spawner. Let's add this in there. Wait for it to compile. Now this is going to be a very quick and simple script, so nothing fancy. Alright. So now that we've added that in there, let me close this. Let me close this. Okay. Let me add the map spawner onto the procedure generation, because why not? So now we have our map spawner script, right? Now our map spawner script will reference the grid manager. The grid manager. Now the reason why we don't have this in here is because we have to add a namespace. The namespace will be the namespace of Gridmap Maker. Dot. Let's do it. Let's do the tutorial. All right. Let's do that in there real quick. All right. Put that in there. All right. That's it. So the grid manager. Okay. Now I've already made some quick scripts for us. All right. I'll show you a quick example of what they do. So first we have the biosphere script. I already made this. Okay. Now the biosphere script simply contains biomes. These ones right here. And each biome will have an associated texture and color with it. Okay. Right. And then each biome will also have what we call a temp rain value. Essentially, what's going to happen is that we are going to use our noise generator to generate a noise value, right? And the closer a noise value is to these one of these values, that will be the biome that it will be given. Okay. So if we generate a noise value that is 0.47 and on 0.37, right? That would be most closest to this one right here, right? And so this is what 0, 1, 2, 0, 1, 2, 3, 0, 1, 2, 3. So that would be a tiega, right? And then we know that a tile at position X or whatever is gonna be a tiega, right? That's all what the biosphere script is doing. Let me put it on the side. All right, that's all. That's it, right? So now let's reference our biosphere script. Biosphere, all right, biosphere. Okay, let me do this. Good. Let's remove this. Let's remove all of this. Good. All right, now let's cut something. Let's create something called public void generate map. Right. So we have these two scripts in here. Now what we're gonna do is we will create another method called initialize. Let's call it init. Right. And all it's gonna do is gonna say, okay, hey, grid manager is equal to get component grid manager. Right. That's it. And then we're gonna say biosphere. Get component biosphere. And that's it. All right. And one more thing we want to do is that we also going to add our noise manager, right? Our noise generator script into this, right? So let's let's also do that. So let's do noise generator, right? Then let's also reference that noise generator. Again, I already made all these scripts before I started this video just to save time, because I don't think it's not that important to the main essence of this video. Okay. So now our noise generators allows us to generate a noise for a given shape. So now what we're gonna do is that we're gonna say, okay, hey, on initialize noise generator dot compute noise. We're gonna compute noises, and then for the grid size, we just use the grid manager, the grid size, right? That's it. So essentially, what we're gonna do is that our noise generator will compute noises for a grid size of grid manager. So if the grid manager is a map that is a 5 by 5 map, our noise manager or our noise generator will generate an array, a 2D array of 5 by 5, right, which will contain the noise values for that map. Okay. Now let's come here to our generate map scripts. So with the Gridmap Maker, the first method you must call is the grid manager that initialize. All right, boom. So now you've initialized it. Okay, the initialize value will initialize all the base values of the grid manager. So if we come here, if you look at the grid manager, these are the base values right here, right? Of course, you can set this either in the editor, or you can set them in scripts, or you can set them in the scripts. Now, for the sake of simplicity, I will set them in the editor. Okay, guys, I'll just set them over here. So let's keep going. Next, we have to create a layer, right? The grid manager works with layers. So now what we have to do is I have to create a layer. Now again, our mesh layer can be done via editor, as you guys will come to see. Let me serialize this class real quick. That way we can then see all these things. And make all these public. Alright. Alright. And alright. So we made all these public, right? Then we're gonna say grid manager dot create layer, right? And then we can simply pass in that mesh layer variable, which we will create in the script, which we will create in the mesh layer settings. Yeah, mesh layer settings, not mesh layer, which we will create in the editor, right? So let's see this. So I'll look at this, and then this will be our base layer, so we can set this to true. Okay. So now that that is done, let's load this program up and see where we're going. And so now, ignore this by the way, this is just some Unity settings, I don't know what to do with them. But if you look at this right now, let's look where we're at. So this is our maps on a script, and we have our mesh layer, right? See, it's very easy. Alright, boom. And then, next thing we have to do, what do you have to do next? Grid manager. Now we have to insert our values in there, okay? So now that we have a layer, now for each position in that layer, we then have to then add a value to it. So we can do this in two ways. All right, let's create another variable, and let's call this public bool block insert. All right, let's make it false for now. So we're gonna make this false. Right. So now that we made this false, we can say okay, for int x equals 0, x must be less than grid manager that grid size that x, then x plus plus, right? Then I think should come in for y, should be the same thing. For int y equals 0, y must be less than grid manager. Come on, grid manager dot grid size dot y, then y plus plus. Right? I've done that, and then we can simply say, okay, grid manager dot insert visual data at position new vector 2int x y, right? And then we then insert, whatever we want to insert. So let's do this first. Let's create a vector over here. Let's call this. Let's create a vector position. Let's create something called a shape visual data, right? And then we're gonna do okay. Position is equal to new vector 2int x y. Excuse me. And then now let's see. Now remember, I told you guys about the biosphere and the noise generator. Okay. So one more thing with the biosphere, I cannot set. And so now that we've done all of this, right? We have to first of all call the init method every time before we run this. We have to call the initialize method. Okay, real quick. So that it would then compute the noises. All right. So now that we've done all of that, so for each position we want to get, what do we want to get? We want to get essentially the biome that's gonna be for it. Okay. So now, fortunately, I've already made this already, but our biosphere will compute the noises, right? And then based on the noise value, it will return, essentially a shape visual data. Now, a shape visual data is what you insert into the grid manager. All right. Now let me show you guys how this is created, real quick. Blah blah blah. So for example, let's say here, for example, we say that for the land value, right? If the land value is below a certain let's just say it's less than the land cutoff, and the land cutoff is zero point 0.5 or whatever, then we will return a new color visual data. Now, the color visual data is simply a child of the shape visual data. Okay, so essentially, what we're gonna do is that we are simply gonna return a color visual data of the, and then passing our shader, passing the color. Boom. Now, right now, our ocean color is gonna be like the color blue. Okay, if it's not, what we instead do is that we have a basic visual here, which again is the basic visual class is simply another shape, is another child class of the shape visual data, right? It holds a texture and it holds a color. If you notice actually, our biome settings, which is the struct that holds, you know, our biomes, actually contains a texture and a color. Okay, so what we're gonna do here is that we say that hey, when we pass in a particular noise value, right? Figure out what biome that is, what biome it is, and then if it's whatever biome that is, get its texture, right? So here we're figuring out what biome it is, which is going to be the biome to use variable. Then we say, hey, get that biome, then get its texture, get the average color, right? Additionally, what we're gonna say is that each visual data must have its own shader, all right? So right now we are using what we call the main shader in our biosphere. The main shader actually, if you come back down into our biosphere, which I'll add here soon. Let me add it in here. The main shader, I have when you download this program, it comes with two shaders, a color shader and a default shader. You can simply use your default shader if you want to create your own, a typical texture and color shader, all right? Now, of course, you can create your own shaders and customize it in whatever manner you want. But for simplicity's sake, you can use a default shader that I've given you, all right? Let's put the land cutoff to say 0.25, all right? And then our ocean color is going to be what? Blue. Texture pad. Then for the texture pad, let's get that. I'll take it what this means later. Now that you understand how this works, right? We first of all, given a particular noise value, we get the biome, right? Then after we get that value, we get the biome's texture and the biome's color to create a visual data, right? And then the render mode is material. And what this essentially means is that because the visual data has a color and a texture. Remember, let me show you this real quick. Visual data has color and texture, right? It has color, right, and it has texture. And by saying that the render mode is material, what we are saying is that hey, we want to use the texture instead another color. Meanwhile, if you look at color visual data, its render mode is actually color. You see this, right? So by default, all visual data gets a render mode of material. But if you wanted to, you can create one for just for color. That's what we're doing there. Anyways, now that we've done that, now we can simply say, hey, let's call this vdata actually. Vdata. So you can say visual data is equal to biosphere dot get biome data, right? Or get what method we're gonna call here. We're gonna call get biome. Alright, get biome data. Is it get biome visual data. So there we go. So we pass that in there. And so we're gonna say, okay, get the biome visual data of this position. Right? Boom. So now we have the position. Now we have the visual data. And then we can insert that in there. Say, hey, position and visual data. And that's it. And then once you've inserted all your positions, we can then say, hey, grid manager dot draw the grid. Alright? And that's it. Right? And one more thing we want to do is let's just create a simple custom class down here. Alright? Let's put it down here. Right here. Let's call this what is this called? This is called the map spawner. And all this is gonna allow us to do is that it's gonna allow us to essentially just call this from the editor, right? Let's call this just make this public. Then we can simply say, hey, call generate map. And if you look at the map spawner, look at the map. Do you see this button right here? We want this button to be on the map spawner. Okay. So let's do that. Let's run this. Now, if you take a look at our map spawner, it should have that button. There it is. right here. See that? It's right there. Let's name this something else. Let's call this generate map. Save this. Alright. So let's see if this works. Right? What do? We've created this. So we need a grid manager, which we've added. We need a biosphere, right here, which we've added. And we also need a noise generator. So let's add that in there. Noise generator. We add that in there. Okay, and there is it. Now let's give it some random values. I don't know what. Let's give it random seed frequency 1 1 1, fractal 1, minimum value 0 1. Same thing with, let's just give it this 1 1 1 1. Let's just we can mess with the noise later, but for now it doesn't really matter. 1 1 1 1 1 1. Maximum value is 1. All right. Now that we've done that, now let's click generate and see what happens. But wait, if we generate, we have an error, right? What's the error? Look at this. We have not initialized our mesh layer. So let's call this the base layer, number 1. So let's call this base layer. Let's leave order in layer to be 0. An order layer essentially means that if you have multiple layers, right, you can determine which layer is drawn first, or which layer is drawn above or below. Okay. Additionally, you also need a shape. Each layer can have its own shape, right? So this allows you to have a map where you can have one layer that's a rectangle, right? And then you can have another layer that's a triangle, or another layer that's a hexagon, right? So by default, I provide the Gridmap Maker asset comes with two shapes, a hexagon and a rectangle. You can create your own custom shapes, all right? So let's just say that you wanted to create your own triangle shape. What you do is that you simply come here, add a new script, right? Let's call this triangle. So let's call this triangle shape, okay? And then what you have to do is that all you have to do is just simply call the grid shape. You have to inherit the grid shape class, right? Now let me open up the grid shape class so you can see properly. So here's our grid shape class. Now that you have the grid shape class, first you inherit from it, and then you will then have to essentially override these methods over here. Okay, so let's just implement all of them. Implement the methods, right? Because remember, all of your classes, whenever you add a shape to a time map, right, the shape must be able to tessellate. And if you don't know what that means, tessellation simply means, right, that the shapes can be stacked. Okay, so if you look at pictures right here, see how they all come together. So this is how a triangle tessellate. Okay, and then let's look at a square, for example. So a square can also tessellate. So this is a square. See how they can stack, and also a hexagon, right? These are the main shapes that can tessellate. Now, of course, if you wanted to create a shape that is 20 polygons, right? That however has no tessellation, you can do that, right? You're not forced to do that, but naturally speaking, this map maker is meant for those who want to tessellate their shape. You can create any shape you wanted to if you want to, but you must understand that if you do that, then you will have to then manually configure how your shape will be positioned. Again, that's up to you, but for the sake of this argument, for the sake of this tutorial, I'll be focusing on if your shape can be tessellated. Okay. So now that we've done all this, now that you've implemented all these, once you implement all these methods, that's pretty much it. That's all you will need to then begin using your triangle shape. Oh, one more thing you would have to do is that you would have to copy this right here, right? So now that if you save this, you then see that. Oh, let's call this file name. Call this triangle. Let's call this triangle shape. Oh, what the? No, what have we done? All right, there we go. We'll call this triangle shape. Now, that way, we can now then say, hey, 1 second. You can then come to your create Gridmap Maker, create grid shape, and look at this, create a triangle shape, right? And then you obviously you have to put in your vertices, your UVs, your triangles, and whatnot, right? If you need help on what's going on, you can. I would recommend that you take a look at the rectangle and hexagon shapes to see how to create your own shape. All right, you can always look at the script and modify them in whatever manner you want. But it's very simple. If you look at a hexagon, for example, it can all be done in less than almost 100 lines of code, right? Very simple. Even with rectangles, even much simpler, right? 7 lines of code, so 70 lines of code. So it really depends on what you're trying to do. Okay. So anyways, let me just delete this triangle shape real quick because it's useless. But that's how you would go about creating your own shape. Okay. So now that you've done that, what can we do now? Okay. So now that we've seen how we can create our own shape, let's keep going and see how far we can push this. Boom. Let's delete the triangle. Delete that. Come over here. Now that we have this, we can then say, hey, let's say you want to create a hexagon. All right. Now I'm gonna explain to you what this visual equality means later, but not now. I won't do it now. So now that we've done all of this, let's create a simple 10 by 10 grid. Let's do a chunk size of 0. Alright, this would be one large grid. Now let's generate this. And now we have an error. What's the error? Let's see what the error is. Biome data. Oh. So what are they trying to say? Let's run through this. Did the biosphere compute? Did it compute? So you see, did we compute it? I think we did. Oh, we didn't. Did we validate it though? We did not. So whenever you, so first you have to like, so you see how our biome settings right now is 0, right? We need this to be more than 1. So all you really have to do is just click validate. Once you validate, when you validate this, it will look for this folder right here. You see this folder? It will look for this folder, and then it will then take these textures, the first 10 textures, and then it will then attach them to each of these biomes, right? So grass 1 will go to tundra, grass 2 will go to cold desert. Now I know it's not realistic, but this is just for tutorial sake. Let's add it in there. Now it's validated. See now it says, hey, the path. See now it's telling us that the path it cannot find the path, right? So look at this is the path right here. So all you really have to do is just copy this path, come in here, paste it, do it again. Boom. Now if you look at it, each texture, each biome has its own texture, and then we get the average color of that texture, right? So that for whatever reason that may be. That way we can draw this with both color and with texture if we wanted to. Okay, that's all we're doing here. So now let's generate the map and see what happens. Generate the map. Now another problem's occurred. What's the problem now? Biome data is 0. Let's see who calls this. Let's debug this right now. We called it initialize. What does initialize do? Have we called the biosphere to I think I have to initialize the biosphere too. Let's see. I think we have to initialize the biosphere with yes. So when you generate, that's right. So lastly, I forgot about this, but you have to then okay. So when you have then computed, the noise values, we have to then pass them into the biosphere, right? So that the biosphere then knows which noise value is associated with which position, okay? And then we'll simply say, hey, grid manager dot planet size, grid size, I should say, right? I mean, let's save this and let's see how this works. Now, if we save all of this, let's see if this works now. We generate the map, and so as you can see, our map's right there, right? It's a simple 10 by 10 map, right? And that's it. That's all you had to do, right? Very simple, very simple. Now, of course, the example I made is a bit more complicated, but I wanted to use a slightly more complicated example just to show you that on the surface, to use the Gridmap Maker is actually quite simple. It's actually very, very simple. Alright, that's what I wanted to show you guys. So now that we've done all of that, now let's see. What we can do then is we can then see, okay, how fast is the Gridmap Maker? Alright. Actually, I won't even do that right now. I'll show you an example of this. So let's keep going. Let me show you the block insert real quick. So now that we've done this, let's do a much larger map. Let's see how long that will take. So let's do a larger map. Let's just say I wanted to make a map that is, 500 by 500, right? Now let's do something let's just draw one large 500 by 500 map, okay? So let's generate this. And this will obviously take a bit more time. Boom. And so now, see how it's laggy? It's very laggy. Why is it lagging? Well, let's see. How many batches do we actually have in this little 500 by 500 map, right? Where's our camera? Let's get our camera in here. And let's make our camera render this. We can do this by simply moving the camera upwards. Let me disable this. That way it's not so slow. So notice that everything's so slow right now, right? So let's get the camera. Camera is like this. Let's this size. Let's see if we can get it in there now. Oh, I disabled it. Let's see if it's in there. So now look at this. So according to our camera, look at that, 88,000 batches, right? And why is it like that? Well, let's see, right? Remember how I showed you guys about that mesh equality, that visual equality, right? So what is going on? Well, let me stop this real quick. Let's not make it go slow. Let's generate a much smaller map and then work with that, and then you see why that happens. So let's generate a much smaller map. Let's generate a much smaller map. So this is a much smaller map, right? So 100 by 100. What is that? That's 10,000 positions. Now this 100 by 100 map has 35,000 batches. Why is that though, right? That's because if you remember, with our mesh layer, right? What did we say? We said that you have this option right here called visual equality, right? What that means is that we can actually group batches that look the same. Okay, so if you notice how, for example, in this map, most of it is blue, right? The thing is that each blue tile on this map is an individual object, right? That's because it's not grouped together, right? So what we can do, right, is that we can do two things. We can use the same tile, right? We can use the same visual data. So right here, so we can use the same visual data to draw all these positions, right? That way we can save on batches, right? That's the first thing we can do. And to show you what I mean by that, if you look down here, do you see how we're always creating for each position? We're always creating a new visual data. If I know, for example, if I know for a fact that all of these are gonna be blue, actually, first of all, I can just use one visual data instead. Okay, so that's the first thing we can do. We can first of all just use one reference, or since we're doing procedural generation, we have no idea what hex would be what, right? Because for example, let's say I change my C to something. Let's say I change my C to this, to 176, and I generate the map. Now, you see how everything moves, everything changes. So you have no idea what's gonna be which and what's gonna be which, right? So what we can do is that we can then call this method right here. This in our mesh layer settings, we can then say, hey, use visual equality. And so what does this do? When you say use visual equality, all what you're gonna say is that hey, for every visual data, right, that looks the same, draw them as one, right? That's all what it does, right? Now, the use visual equality is very important, right? If you were to create your own custom shape visual data, you would have to then call that method on your own accord, right? So the use visual equality uses this thing called here. It says it is this method called the visual hash. Now it is up to you to create your own visual hash. Although I have provided for you a default visual hash. Right here, let me show you the default visual hash. I have a default visual hash for you, right? But it's very slow, right? So I would recommend that if you were to create your own visual data, you override this method over here. Where is my method? I recommend to you that you always override this method right here called the get visual hash, right? Because when we are trying to group these tiles together, how do we know if how would we know if two tiles are the same? Well, it's very simple. What we can do is that we can get all of the values, right, that are used to generate a tile, and then we can get their hashes, right? So such that if two tiles have the same hash, then they must look the same, right? So if you look at this simple function right here, for our basic visual, what are we doing? We simply get the hash of the texture and the hash of the color, right? Such that if two tiles have the same texture and the same color, then they must be the same. Now look at the amount of batches we have in here. That's 44,000. Okay. So let me run this program. That way you can see what FPS you would get if you didn't use visual equality. So let's generate this map one more time. What's going on here? Oh, it's an error. I don't know what error is going on here. Let's see. Let's debug this in real time. So let's debug this in real time. Let's see what's going on. So this is actually null. Why is this null? Well, this is null because it's ordered volumes. Ordered volumes. Let's see. Let's find all the references for this. This is being set over here. Alright, so what we can easily do is that we can simply say, hey, you can just set this here and just say, alright. For some reason, it's not saved during build, during play, but that's fine. Call this in here, save it all. We do that. Now let's rerun this. Let's close this. We close this. Now let's take a look at this. So look at this. So now it's ran, right? Let's run. Let me generate the map. So this is the map right here. So alright. So wait. Let's generate the map. So look at this map. This is the map without visual equality, right? Look at the FPS. 27. Now, of course, as you all know, the FPS in editor is usually about 5 to 10 times slower. At least on my computer it is than in build, right? So even in build, that 25 FPS you see down there will probably be like will most likely be something like, you know, 125 or 125 or 250, which is pretty fast, but still, this is a very small map. This is only 100 by 100, right? And now let's see what happens if we were to use a visual equality. Now watch this. If we were to use our visual equality, we can then say, hey, generate the map. Now look at FPS now. 87, 88, 89, right? That is by simply using a visual equality. This is why it's very important that if you get to use your own, create your own visual data, it's very important that you override this method. You override this method and create your own visual hashes. All right. Now let's see how far we can push this. Let's generate a much larger map, right? Now, one other advantage of our map is that we offer a chunk system. So right now, if you look at this map, it's just one huge map. Okay. Now let's see what will happen to our FPS if we generate the same map, right? But with a chunk. So let's do 50 by 50 chunks. Not much of a difference. You see, there's not much of a difference now, right? But the thing is, now that we have this chunk system, we can then disable these chunks on their own accord, right? If I disable these two, I can then begin to get even faster FPS. It's not as visible because the map is very small, but if you were to run this in the build, you will very quickly see that this is actually a superior, you know, means by which you can generate your own maps. So let me do this real quick, right? So let's generate a much larger map, something like 1000 by 1000. Large map. Let's make the chunk size 100 by 100. This is going to be a very large map. Right? This might take a while. So let's see. Just see how long. Let's see how long this takes, right? Because remember what we're doing here is that we're doing this individually. If you go back to our map spawner, This is all being done individually. So let's see. Look at how long this takes. It's still going. I can. Unity is frozen on me. It's taking a very long time. Come on. It's still going. It's still going. It's still going. It's still going. Right? Let me begin coding up that block inside right now. So boom. So this is not the large map we made. Look at this, 1,000 by 1,000, right? But now it's made of chunks instead. So it's obviously if you're making a game, right, you wouldn't create, you know, you wouldn't show all this to the user. So what you can do is that you can then simply individually disable these chunks, right, and begin to save on FPS. You can just do that individually. Let's just do this. Let's just disable these ones too. Why not? And you can easily begin to save on FPS. It's not as visible in the editor, but in the build, just by disabling these chunks, you can save so much FPS by doing that. Very easily, very easily. All right. Anyways, now let's clear this grid map. Ah, damn it! I didn't create a clear method. So let's first of all create a clear method. All right. Now to clear the grid map is very simple. Just call gridmap clear. Right. Now let's also create a clear button down here, and then we can simply call the clear method, which is this one. That way it clears it out. Now see what happens when we do a group insert. So instead of let's just use var, because why not? Now if you look at this right here, when you call get data, it simply gets the dictionary values, right, and returns a tuple, right, and then we can then insert them as a block. Now see how much faster this would be. Let me stop running this. Let's wait for it to clear out. Now let's see how much faster this would be with this. Let's save all of this now. Call this. Everything's cleared, right? Now let's generate that map one more time. Let's generate a 1,000 by 1,000 map. Now let's look at this. Look at the speed over here. Again, the same map. Did we enable block insert? We did not enable block insert. Oh god. Can we stop this? No, we cannot. So I didn't enable the block. I didn't set it to true. That's a shame. That's a shame. Let's just wait for it. Let's just wait it out. Wait it out. Wait it out. Oh god. Wait it out. Wait it out. Come on. Is it loaded yet? Nah, it's still frozen. You know, and strangely, it's not normally it's not this slow. If you look it up, oh, there it is. You know, it's actually much faster than this, but I don't know what's going on today. It's just much slower. No, it's not that. It's not. So the main. So by the way, just so we understand, the map itself is not taking long. It's not taking. It's not the map that's taking a long time to draw, right? So let me show it to you guys real quick. Let's give it a random code 23. Generate time. Let's call this. So let's time log. This is my own custom script I made to stop timer. This is my own custom script. This time logger class. So my point is that that time it takes to generate the map is not actually it's not actually the map that's been generated. It's the actual compute time for these values, right? And I'll prove this to you with this code right here. So let's clear this. Let's stop running this for a second, and then where is it? Come on, save all of this. Come back into Unity. Let it recompile itself. All right, now watch this. Let's run this. Again, I will not use block insert. Okay, I'll just do it. I'll just do it normally individually. Now let's see how long this will take us to do it. What the hell did we? All right, we didn't have to update these numbers. All right, so now we generate the map. This will take a while. I will most likely just skip this. Well, I don't want to skip it because I want to be. I want to show you guys I want to be honest with you guys, so that you can see that in real time what's taking time, what's taking so long for these things to draw. And my point is, I want to show you that it's not the API that's slow. It's the actual generation. It's the actual compute time for the noises, right? This is what's slow. This is what's slowing us down right here. This compute noise time, and you see this once it's done. So look at this. I don't know how long that took, but the generation time actually took only 15 seconds, right? So that the time it took from us to actually create this map to run this code you see right here, that was only 15 seconds, right? Now let me show you what will happen if we use the block insert. Okay, so right here, block insert. And if you remember, all what we're gonna do with the block insert is that we're gonna say, hey, instead all of these positions at once. All right, remember this. Let me show you this right here. As all we're doing is that we're gonna insert them at once. Now watch this. Generate the map. Come on. Come on. And look at that. So if we use block insert, it only takes us what? 6 seconds to generate the map, right? So it's just something I want to inform you guys of. And one thing I think we can actually do is we can actually just parallelize this for the most part. Can we see if we can parallelize this? We can, generally speaking, just parallelize this. Wait, let me do something real quick. Let me remove these. So let's see if we can actually make this even faster. Just remove this part right here. If we remove this part, easy speed wire. Let's look at this. This code I just canceled out was just to see the percentage of the distribution between these noise values. All right, it doesn't really mean much. So let's can we clear this grid out first? Let's clear this out first. That way you don't have to take forever to unload this. Okay. So let's see this. So let's just run this right here. Generate map. Voila. All right. Let's see if we can then do something even bigger. Generate map. Come on. So yeah, it took 2.7 seconds to draw, you know, our 500 by 500 map. And then, of course, as you guys know, you can easily just mess with these values, right? You can easily just change this to like Berlin or whatever. And that's the thing about these values, that is you can easily modify them whatever manner. And if you look at this, that's all you can do, right? It's very you easily just change the map by also create some new values. So if you look at it, again, new values. Anyways, that's pretty much it for this video, guys. As you can see, it's very easy to use this map. I know this has been a very long tutorial, but um, it's very intuitive. It's very intuitive. It's very fast. I think this is much better than using. Once you get the hang of it, it's much better than using Unity tile map. If you want to create your map just through code, right? So there's very little editor support for this. It's mostly just through code. So if you're the kind of guy who will be making a map just via code, right? Or if you want to create something like a procedural generated world, or if you're gonna be using textures to call it, or your own custom textures, your own custom materials, your own custom shaders, this is the map for you, right? Because you must remember, all these tiles you see down here, bro, all these tiles you see down here, these are all essentially materials and shaders, right? So for example, if you wanted to animate this ocean right here, you could do that you could do that, right? You can easily animate the ocean, right? You can easily do it. If you wanted to, make the trees, whatever, you can do whatever you want, right? You can use whatever shape you want. You can use whatever size of the shape you want. It's all up to you. Everything is up to you. That's all. There's so much customization possibilities with this map that I would always recommend that if you don't need that editor support from time apps, then use this instead. And goodbye.